fell in love with all these slides, so I couldn't get rid of them. So I'll probably run out of time. So kick me, Rick.
All right.
So I was thinking about. Let me show you where this started from. Forward.
Big button on the top.
Yeah, it's not working. Sorry.
He's helping me.
Not working. The green one.
Yeah, that's the right one. It's just stuck.
Okay. This work came as a result of work I did when I worked for BP for 12 years in the Chief Technology Office as a technology director. And the way we worked there was to scan the markets for new technology that was about to come into being or come into actual use about 12 to 15 months out. And we would look at Silicon Valley, make a trip to Silicon Valley every year, and a trip to Boston every year, and then talk to the military who have great technology, especially in this, I'll use the word drone, it's unmanned aerial systems, but okay, drone, everybody likes drone. And then we would, and this was all outside of oil and gas. We didn't look at things from Halliburton, things from Schlumberger, Emerson, people like that, because other people in the business were doing that. We looked at things like Facebook, like Google. I went to Google in 2002 when they would probably fit in this room. They were in an old shopping center, old shopping mall, strip mall. So one of the things we came across was robotics, and in robotics, unmanned aerial systems is one of the types of robotic platforms that we looked at, as well as crawler robots. And so as part of that, we did a lot of different things with the drones. And there's a list of different sorts of applications we actually piloted or put into production. But I was thinking about the theme of this conference, and I thought, well, which of these really has to do with the cities of the future, or smart cities? And this example is going to be from Alaska a couple years ago. And so it might not be obvious how it fits, but I'll try to explain that to you. So I picked out this mapping, and I ended up calling it digital civil engineering is the name I put to it. So that's what I'm going to talk about. So how does this stuff begin? Well, I got a call from a projects manager. So these are the people that do the major construction projects. I think the cutoff was 3 million or something like that. If it was over 3 million, then it had to be done globally. A guy named Grant Smith, actually, said, we're going to be doing some major work up in Peru Bay next year, which would have been 2014. And we're worried about all of our workers that are going to be out in the field, because when you have snow or blizzards, which you can get some really nasty blizzards up on the North Slope in Alaska, you can't see. So you can end up with people stranded at facilities without food and for days. And you basically, as shown here by the phase conditions, you can not travel. So the only way they get to them is they actually take one of these road graders, and they put a convoy behind it. And then they drive the road grader down the road, which, by the way, is 2 meters or 6 feet approximately of gravel fill over the tundra to keep the tundra from melting. They construct these roads above grade, and that way the tundra doesn't thaw out and sink in the summer. So if you go off the side of that, it's kind of a big problem. You'll end up like rolling over. So the guy in the grader would put the blade down and feel the edge of the road, go on, slow, 5 miles an hour, but feel the edge of the road, then the other trucks line up behind him and follow him. Mm. And so we thought, oh, well, yeah, you've got these farm things, right, like tractors that go back and forth and sow seeds and combine everything. Should be able to do something like that, right? So we went to Trimble, and there's other companies. Trimble's one, John Deere's one, there's other ones, but those are kind of the big ones that said, can you guide this road grader with your GPS guidance technology? And you're saying, what's this got to do with drones? I'll get to that. And so we put 2 of those precision GPSs on the road grader. That's where they are. And then that's the display. And this is the correctional GPS tower. And so in order to get the GPS down to centimeters versus, I think in the US it's about a meter, 5 feet, a meter. But if you have a correctional tower, that's what they use for agriculture, then you can get it down to a couple centimeters of precision. So we put that on the road grader, and then if you could click on this little video, please, for me. I can't do it from here. The guy that's, this is the chase vehicle, that's our grader. The grader operator, think of the convoy land. He's watching that display. He has his coffee there. So he can actually follow that display and go right down the center of the road. And then you can see we put a pilot IFR training hood on him so he couldn't see where he's going. He couldn't see except for the display. So we said, wow, this is it. This is what we want. But what's the problem? And what the problem is? The problem is, hey, our maps aren't that good. Yeah. So if we use the maps that we had in the system, which were done with aerial photography by a company called AeroMap, but you would end up going off the road all the time because they were not intended to drive vehicles with, right? They were intended to look at the map and visually drive around. So we said, uh-oh, we got a problem because we don't have maps that are that good. So what do we do about that? So we looked at, well, how do you actually get a more accurate survey? And we looked at sort of 3 different ways of doing it. The first would be to have the guy out there, see the guy with the stick that's right there, and he would actually survey it. Well, that's okay, but it's like $10,000 a mile for to do it every 10 feet. And not only that, you could probably employ all the surveyors in the US and it'd take you a few years to get the whole thing done. There's about 260 miles of roads. So that was kind of out. Plus, it's an interpolation. You've got every 10 feet. You don't have every inch. You've got every 10 feet. So you're still going to have lots of issues. So no, we can't do that. Then you can get like an airplane, and you can fly over about 5,000 feet, and you can map with the LIDAR. And that's pretty good, but the resolution's about, it's about 8 centimeters, and it's pretty pricey to do it. So, okay, maybe, but probably not. So we ended up looking at how you could do it with an unmanned aerial system. And so that really worked out well because it was pretty cheap and you could fly low. And I'll give you a side story real quick. At the same time, the FAA had come to us and said, they asked for a private meeting with the oil companies. And they said, you guys need to go fly some drones because we need to get some drones in the air because Congress is beating the crap out of us on not letting anybody fly. And if you fly them in Alaska, it's like, who would care, right? Plus, you're in a controlled oil field space, so it's pretty safe. It's not like you're flying around the neighborhood. You've got a lot of controls in place already. And so we said, hey, we'd like to do this. And they said, yeah, okay, we'll support you on that. And so we ended up flying the drones around and said, yeah, this works really well. But it's kind of hard to justify it just based on this Phase Convoy Navigation. So it's like, gee, what else can we do with it? And so the roads, pads, and remediation, people said, it's really a big problem to maintain these roads. I took the numbers off because probably BP would not like me putting numbers up, but it sort of varies from $25 to $70 million a year for the road maintenance and construction. Depends on what's going on in the year. But so we said, oh, if we could do that, then, and we've got the same technology I just showed you, right? Then we could maybe make this thing make sense and solve a lot of the issues they have, which is basically they don't really know where the road needs fixed because they really don't know where the high spots and the low spots are. So they just do all of it. Well, doing all of it's pretty expensive, right? And they have to pull gravel out of the gravel pit, which is about $25 a yard when you get it out to the site. There's a lot of yards of gravel in 250 miles of road. And they had this problem with the drill rigs falling through the road. So the drill rigs are almost as wide as the road. And if you've got about a foot or two on each side. And I'll give you some more on that in a second. But every time they go off the road, it's $1 million, which is, it adds up fast. Why? Because it's expensive for the rental, plus it's expensive to get it out. It weighs 5 million pounds. But so a lot of reasons you'd want to do better with the roads. And so why the roads kind of, problem? Because they're gravel and they move around. As you plow, they move around and they sort of drift here and there and the stuff goes off the side. So big issue. So we just took sort of the same technology and said, okay, if we had these maps, then we could actually make this happen. And I talked to the Google self-drive car people at the same time. I had a call with them, and they said, oh, you're just doing what we're doing with our self-drive cars. And an insight they gave me, too, that was kind of interesting, is they said, and we don't really care about the cars. What we're really doing is collecting all the infrastructure information along the road. As we go down and we use LIDAR to map the road so our cars can follow the map. We're also getting the road signs. We're also getting the wires. We're getting the telephone poles. And guess what you can do with that? You can sell that stuff. We're getting the damage to the road. That's actually where the money's from. It's not from driving self-drive cars around. It's from all this data you're collecting. So let me show you, please click on this. This is what the UAV looks like. We haven't seen one yet, so I thought I'd show you real quick. And this was with AeroVironment, who's out of Semi Valley, real innovative company. So here they're hand launching it. That one weighs about 20 pounds. And they put extra long wings on it to hold the LIDAR, which actually the LIDAR came out of Mercedes-Benz cruise control. But and so once you put it up there, then it just goes back and forth, back and forth, back and forth. And I don't think any man pilot could actually stand to do that. You can fly it into up to 55-mile-an-hour winds, and it stays within a few centimeters of the track. So that's looking at the road in the winter. Sorry, that's a road with tire tracks on it. And then this is a really interesting part, is when you process it, that you get this kind of an image. And then it's outlined, it's auto outlined the road in the center line. And you see that slough off on the side, that's where the road caved in. It's also where you'd want to go scrape the gravel up and put it back. Instead of doing the whole thing, you go, oh, I actually have to go do that. Okay, I don't have to do the whole thing. So instead of doing this, all these miles, you just do like 10% of it, which is what really needed to be fixed in the first place, thanks to AeroVironment. I talked about the drill rig movements a little bit. So then people said, oh, if you can do that, maybe you could guide our drill rigs. These things are about 3 to 5 million pounds. They're just about the same width as the road. The way they did it was they have 4 guys stand on the corners of the drill rig with radios, and the drill rig's actually got a little slot. I think you can sort of see that. It's like a tank thing that you look out of, so you really can't see. And the guy with the radio says, go right, go left, go a little bit, stop, go, forward. And so every once in a while they get too close to the side, and it doesn't like roll over, it just kind of gets stuck, right? And then you got a problem, because now you just block the entire road, and you can't get to your drill site, so you're spending money, you're not making money, and you're also blocking the road. So there aren't that many roads, so to get to where you want to go, you've got to go way out of the way to get back, so big issue. So of course we said, oh, if you put that same guidance technology on the drill rig, then you could just have that display, and you could actually drive these things by themselves. People aren't quite ready to make that leap. You really don't need the driver, but need somebody like a safety pilot in there to watch it. But you could actually do it without a driver better. And the other thing that was stopping these people is they couldn't drive in the fog or the blizzards. But with this, you could do it because you know where it is. But it goes back to you got to have the map. Well, how do you get the map? You run the LIDAR system off of the unmanned aerial vehicle, and you do the precision mapping, which, by the way, if I didn't say it, it's like 1 centimeter XYZ is what you get with the map, which is pretty amazing, right? So then we got to the gravel pits. This thing just kind of keeps going, right? But the actual flight you saw was actually over the gravel pit because it was safer to go over the gravel pit. It was just like a test flight. Well, then it turned out that, gee, that's pretty interesting, because the way it works, or it did work, was they counted the gravel trucks going out, and they said, okay, you took this much out, so that's times this, and you took this much out this year, so you owe us $3 a square cubic yard, and you pay the borough that owns that gravel, which is just part of it, because you also have environmental considerations. You're digging down in there and you're destroying the area, and then you've got issues with flooding and everything else. So with this system, you could actually just fly over it and do the volume, and then you go back at time plus X, and you fly over it again, you just do the difference. What's the difference, right? How much did I take out? You know exactly what we take out? Show the state that instead of a bunch of hand tickets saying, oh, this truck holds maybe so many cubic yards, and that's what we owe you. So that was a big deal. And then here's kind of some of the products you get out of that. These 3D models, which are, I think we did 5 meters, but it also gets you into another interesting thing for cities, which I didn't bring along, but we started doing like dams and landslides, right? So if you image dams and landslides, you can see if there's, and you do it over time. I called it 4D modeling. So 3D plus a time dimension, you could actually see, oh, this place is going to go because it's, look at it, it's creeping down the slope. So if you think of like the Oso landslide up in Seattle that killed all those people north of Seattle, you could have actually seen that. Or there was the Rock City one in Utah that it came down and just buried a house, and they just left it. Said, yeah, there's nothing. If you drive around Salt Lake City, where I've been recently, and I look at some of the construction on the old lake bench, I go, oh my God, who permitted this? You seen that? Like the old, the Salt Lake, what'd they call it when it was higher? I forget. Back 10,000 years ago, it was about 500 feet higher, and you can see this bench along there. It's just like beach deposits. They've got houses right on the edge. I'm a geologist by background. I just go, oh my God. So you'd really want to be monitoring that stuff to make sure you're not going to have a landslide happen anytime soon. I think it's a really good area for looking at the use of unmanned systems, is how do you actually use that to avoid disasters. So here's a solution summary, which shows these are well pads. They have to build everything up above the tundra with the drill rigs on it. This net's just the LIDAR with the UAV there. Do some with communications with satellite, that's what that is. And then you've got the drill rig moving along the road, and the graders going along doing their thing or doing phase convoy navigation. Then we also get into, well, this out here, there's hardly any relief there, it's just feet. And so a lot of the drainage is really not where it should be in the culverts and everything. And so you can actually go back and say this is where they should be. They had a huge flood in 2016, and a whole bunch of stuff flooded, so they got real interested in, okay, so where should we be putting diversions, dams, where should we be putting drainage and stuff like that? And the thing I didn't bring along, which is kind of cool that I'd like to show you sometime, is you can get these little crawler robots and send them through the culverts to see if the culverts are in good shape, if they're going to collapse, which they collapse a lot from basically erosion from the flow. And you can't put people in there because it's confined space. And it's also, some of them are way too small, so you couldn't go in there. So the technologies involved, and I'll wrap up here, is LIDAR to create the maps. The LIDAR, by the way, does 30 or 40,000 dots a second. Can you believe that? It's light speed, right? It goes back and forth like that. They call it push brooming. And then you've got to translate those points into an actual map. There's some processing there. And then you go to the software to do those differences. I was showing the video, like where the road center line is, where the slumps are and stuff like that. They do your GPS guidance system supported, augmented by virtual VRS's virtual reference station. Sorry, that gets you from the kind of 5 meter down to the centimeter resolution. It's not that bad. I think to cover 350 square miles there, it's 3 stations. It's flat though, so it's not bad at all. And then you have your semi-autonomous, and I just put semi because some of the drivers, it's like, there goes my job, so we still you need us, but it's really could be autonomous vehicles that you're going to use to navigate with. And business is really about saving OpEx, do it by doing proactive maintenance, only doing what you need to do versus everything because you really don't know what you need to do, avoiding these off-road incidents, and keep all the work moving in spite of bad conditions. What did we learn out of that? You need a correctional GPS network. Trimble has one, it's called VRS, not that bad, I just said. Having a local service is really important. So they would fly from California and do this, right? The problem is, like I mentioned, the flood. Okay, we need them to go out and do the flood surveillance. Well, it's a day or two to fly up there and set up. So if you have somebody on site, better. We decided to outsource it because it's just really fast-changing technology. You have to have commercial pilots to do this stuff. The sensors change, so we said, you know what, we're going to buy it as a service. Side thing is get the people to price it out in terms that your users understand, like per mile or something, per foot, something that they can relate to. Work with the FAA. They're really pretty easy to work with if you work with them, and they're helpful. They've got their rules, but they're not really that hard to comply with. In fact, it saved us a couple times because we had a pipeline patrol pilot call in and say, there's a UAV operating in this area and it's illegal. And we had done the whole filing with the FAA, the report saying we're going to be flying there, and we had their permission. So the guy that called in got in trouble for not doing his homework before he went out to fly. And then LIDAR processing, I haven't looked at it for a couple months, but it was pretty expensive and slow. So if you could accelerate that, if it takes 2 weeks to get your result, not so good. You really want to have it almost instantaneously, right? Depending on what you're trying to do. And then one thing I learned out of all this too is that you're competing with existing services for the most part. So you really need to look at like 3 things. Am I going to be more cost effective? And hopefully that's an order of magnitude more cost effective, like we saw with the manual surveying or the aerial surveying. Am I going to be safer? Pretty much, usually you're going to be safer because you're not running around on the ground doing stuff. And then finally, is it faster? Can you do it quicker? So if you kind of draw a triangle and say, yeah, I beat all those, you've probably got a commercial offering that makes sense. And this is, this project actually, I'm the guy with the yellow stripe coat, but this project actually was awarded the first commercial license to fly over land in the U.S. In June 6, 2014 by the FAA. There was one before that over the Arctic Ocean with ConocoPhillips, but this was actually the first one to go over land that was actually endorsed and permitted by the FAA. Thank you.
Great.